Hi, my name is Agnes Ng from Group 1-3 and I will be presenting for introduction, problem statement and objectives. Coal is one of the most significant sources of energy that powers almost half the globe. Despite its abundance and low cost, coal-fired power plants impact Earth negatively from its emissions. Sulfur dioxide emitted decreases plant yield as well as form particulate matter and ground-level ozone. Flue gas desulfurization (FGD) is the most common method to reduce SO2. Limestone is typically used to react with the gas to achieve over 99% removal efficiency in the spray tower. Hydrogen peroxide can be used to replace limestone to only emit sulfuric acid. To optimize the FGD process through controlling hydrogen peroxide flow rate and concentration, PI controllers with fuzzy logic are utilized. FGD in coal-fired power plants to remove sulfur dioxide using PI controllers was decided to be studied. Coal-fired power plants emit sulfur dioxide which negatively impact the environment and humans. To optimize the FGD process to remove SO2 and maximize its removal efficiency, factors such as flow rate and concentration of H2O2 are maintained using PI controllers. Therefore, the objectives of this project are to propose an appropriate FGD system equipped with PI controllers, and to optimize the FGD system through parameter tuning using fuzzy logic.
Hi, my name is Kenneth Chong, Haur student's ID 19001147. For this project, I will be in charge of proposed control systems for SO2 emission process in coil combustion.
In these systems, Fuzi PI control systems is used due to three main elements: proportional actions, derivative actions, and Fuzi logic. Proportional actions allows the controller process gain to have more faster response. However, it will produce offset throughout the process. Hence, derivative actions take place to eliminate offset in the flow rate of SO2 outlet streams. With the addition of Fuzi logic, it can assist in the eliminations of the complexity of both conventional PI calculations, and it helps to produce a better control performance in SO2 emissions control process. How this control system works? At first, the outlet SO2 gas was measured by using flow transmitter 103, and then the signals was transformed and transmitted to FIC 103, which is the controller, and the controller will transform the signals to produce output signals through electrical signals to FY103, which is flow transmitter, and flow transmitter will convert the electrical signals to pneumatic signals to control the FB valve so that it can control the flow rate of hydrogen peroxide inlet. So when the outlet of SO2 gas increase, the valve will increase the percentage of opening to increase the flow rate of hydrogen peroxide inlet so that it can reduce the SO2 gas admit to the surrounding area. So based on this controller design, we can clearly see that besides on conventional PI controller design systems, a Fuzi inference is added into these controller systems in order to enhance the complex calculations. So based on the calculations, the integration between Fuzi logic and PI controller activities, and then by applying the parameters range set, and we have come out the equations where ut equals to 0.7 et plus 1 over 17 with the total sum of error times th sample time.
Hi, I am Nurin Faqihah and I'll be explaining on the critical analysis and discussion that relates with environmental and chemical engineering elements. It is crucial to reduce the emission of sulfur dioxide before being released to the atmosphere, as it brings detrimental impacts to the environment and human health. This is because sulfur dioxide is an acidic gas that readily combines with other chemicals to produce harmful compounds such as sulfuric acid, sulfurous acid, and sulfate particles. It is also a precursor to acid rain, which has negative impacts on forests, freshwaters, and soils. As a result, insect and aquatic life form die, paint peels, steel structures corrode, and stone structures and sculpture weather. Additionally, it can irritate the nose, throat, and airways when breathed in, with a chance of developing more serious problem over prolonged exposure. In flue gas desulfurization process, hydrogen peroxide is used to enhance the absorption of sulfur dioxide in achieving higher removal efficiency. Hydrogen peroxide is safe to store and will not cause secondary pollution as it is a non-toxic and non-polluting substance. Since the flow rate of hydrogen peroxide has a direct influence on the sulfur dioxide absorption rate, the flow rate of sulfur dioxide is manipulated based on its concentration, leaving the column to obtain effective sulfur dioxide removal efficiency, which can be done by the proposed control system. From the graph, it can be observed that sulfur dioxide removal efficiency increases with increasing flow rate of hydrogen peroxide solution. This happens because when hydrogen peroxide is sprayed to the scalp flue gas containing sulfur dioxide, it oxidizes the dissolved sulfur dioxide and forms soluble sulfuric acid. Hence, it can be concluded that hydrogen peroxide enhances the oxidation absorption of sulfur dioxide in the flue gas. In addition, the removal efficiency of sulfur dioxide increases with the increasing hydrogen peroxide concentration. When the concentration of hydrogen peroxide increases, the time taken for the desulfurization process decreases, which will have a direct influence on the absorption.
Hi, I am Nurul and will be explaining about the challenging concerns of process control.
First, it will cause reset wind up to the system as it unable to react quickly to the changes in the control error because it has reached the maximum saturation. Next, the oscillatory or rolling nature of the process response is more pronounced that cause the system to be unstable because the integrator may still be impacted by the pulse fault. And lastly, the challenge is to control the large time delay process as the terms act as the barrier for the quick close response if the time delay is significantly more than the process time constant.
Hi, my name is Darren and my ID is 190011351. And here I will present about the recommendation for the proposed control system.
In recommendation, a new approach which is multiple variable FPID control system was introduced. This method is the combination of fuzzy and PID controller into the predictive control framework to create a new FPID control system. This control system can produce an incremental control actions as well as modify the controller parameters. The plant outputs are predicted multiple steps in advance by the fuzzy predictor. In order to minimize the error between reference trajectories and expected plant output over the prediction horizon, the parameters are changed. The simulation of FPID control system also shows that it is suitable for both SISO and MIMO nonlinear control problem, and it has a high trajectory tracking adaptability, disturbance rejection, as well as the robustness to the noise features.
Hi, my name is Imran Mansor. To conclude, coal industries have been harming the environment through sulfur dioxide gas emissions. To mitigate the situation, a flue gas desulfurization system equipped with fuzzy PI controllers is proposed, in which hydrogen peroxide flow rates is manipulated towards the desired outcome. However, this process has several setbacks, in which reset to the wind-up system, oscillatory response, as well as difficulty in handling large time delay process. To overcome this, multivariable FPID can be utilized, in which it produces incremental control action by modifying control parameters and minimizing errors.